I'm Jason Lear, and I'm the builder of this pretty interesting remodel. This is where the house used to be. We lifted it up in the air just about 2 feet. Now that didn't get us a basement. We also had to dig down. So this is what we built these walls out of. On a site, an urban site like this, where we're right next to the sidewalk, this is a great way to build. We get the hole dug. We put the footing down, of course, first, and then we start stacking these right on the footing. So it's kind of like a giant styrofoam Lego. You see these little nubbins here? Well, the next one stacks on top of this, and these guys insert into these holes. So in the end, we have this 8-inch thick concrete wall with a casing of 5 total inches of rigid foam. Stack them up to full height. That's another interesting thing about it. This is a concrete basement all the way to the tippy top. A lot of times we build concrete basements to here. As soon as we get above grade, we stop and we put what we classically call a cripple wall on top, right? That's an appropriate name. It's the place where homes in this kind of seismic zone fail. This is a great seismic solution. Concrete's reinforced all the way to the top. It's also a great thermal solution. So a lot of people ask, how do you get water, pipes, and electrical into a wall like this? It's pretty simple. You can kind of see it here. You simply cut some of the styrofoam out. We cut a channel into here, brought the water line in, and it's headed up to the joist to distribute through the house. So this is the transition from the new to the old. And the question that comes up on a house like this is, okay, it's an 1897 house. You just lifted it up in the air and put a modern, well-insulated, seismically almost perfect basement underneath it. What do you do with the rest? Is it worth it to do that? I mean, don't you have 2x4 walls above, and what are you going to do with that? You know, this is, sure, it performs great, but what if this doesn't? And it's a good point. Right. What we realized when we opened the walls on this house is that this 1897 house is balloon framed, and something clicked for us. So this is balloon framing. The wall runs right up past the floor. There's no floor interrupting. This is what makes this house a perfect candidate for spray foam insulation. We can get the foam up behind the floor diaphragm such that it's continuous. It runs all the way up the side of the house. Well, now you've got a situation that's more like the new basement we built. Continuous insulation running really effectively from the ground all the way up over the house. So part of how we make this work, this is a 2x4 wall. It's a little bit thicker 2x4 than average, but it's still just shy of 4 inches. Even with spray foam, that's not a lot of foam. Also, if we were to just spray foam between these stud bays, it would be foam, stud, foam, stud. In these spots where the studs are, the R value of the wall is much lower. So all we're doing is adding another ½ inch of foam that runs continuously across the face of the studs. That's the point of these little metal cross straps. We'll spray to the surface of these, we'll shave the foam off at the surface of these, and in the end, we'll have at least a portion of the wall that is continuously insulated. And the payoff here, we had to find the smallest furnace we could find, just so this 1897 house doesn't have too much heat in it.